Okay, so here we go. My name is Angela Tyler, and I am the VME Program Manager at the Image Center. VME is one of 19 programs that we have at the Image Center. And this particular program is really for people with disabilities, and we team our volunteer engineers up with our OTs, PTs, and nurses, and they come up with these amazing solutions for our clients. We primarily serve 7 counties, but oftentimes we sometimes expand that as well. So when we have clients who need repairs to walkers, or if they need special customized items, we'll work with them wherever we go. So today we're going to talk about 3D printing. And the reason why this came up is because one of our dear volunteers, Rod Boudreau, who this particular workshop is dedicated to, he was an electrical engineer. He passed earlier this year, and he donated a 3D printer to us, which actually is housed at Shelbi's home. 3D printing is something that we've been doing for years, particularly our school teams. We work with 11 school teams throughout Maryland who actually come up with solutions, and a lot of their solutions include 3D printing. So we thought that we would have a basic workshop this time just to give everybody a feel for some of the solutions that we do, and maybe you might want to do some of these at your home. So it's really exciting to see what's been happening. With that said, I think we're going to go ahead and start with some of the solutions that we've created, and then I'll introduce you to Shelbi, just to get, just to give us a baseline. So let's pull up the screen here. Are you guys able to see?
Yes.
Okay, let's.
Yes, good job.
Okay. Let's kick it off with a solution that was created by Marlene, who is actually on our call today, Dave, who's on our call, and our dear Rod Boudreau. We received a call from a woman who was in a fire whenever she was 5 years old. She ended up having third-degree burns through that childhood fire. She did not have, well, actually, she started off with a walker solution, but for years she did not have a walker solution. So she needed something that would allow her to basically get through her home, and something that would be comfortable because she had amputations on both arms. So if you can see that particular solution on our left, the pink solution, it was actually created through a 3D printer, through Rod and through Dave, and it was attached to her walker through the skills of Dave Hall. With the help of our OT Marlene, we realized that she really needed some more comfort. So special cushioning was added, and now Jacqueline is using her walker. She's an amazing woman that we all really, really came to appreciate. So that was one solution.
If I could just add to that, the thing that I thought was so valuable about this particular project was that Jacqueline did have a walker attachment, a platform, but it broke. And it broke, I don't know, Dave, if you can remember, like it was like several years that it had broke. And we were saying, like, so what did you do when it broke? Did you ask? And she said she asked everywhere. And there was just no one that could resolve it. So I think I asked her about 3 times how many years she had been with it broke, that she couldn't function, because I just couldn't believe that she could go so long. So I just thought, with Rod's ability with a 3D printer and just the whole way he designed it, the fact that finally this young woman was able to find a solution, and that's pretty much what VME does, find solutions. So I thought this was really representative of that no one else was able to do it except
this was really fascinating for all of us, because what you're actually looking at is not the final solution. The thing that was wonderful, the 3D printing, we could make something and try it with the client and find out the problems And basically what we found out, the end of her arm was so sensitive, she needed something I'll call like a donut hole type support. So Rod went back and redesigned the whole thing and printed it, and we put it on there. So the beauty of the 3D printing is you can rapidly get a, proof of concept type thing. And Marlene gave us this plastizote as a cushion stuff, and you can see it's kind of rough here, but within like a week or so, he could go back home, redesign it. We could meet them, and finally, well, the second try actually came up with a solution that worked for her. And yeah, it was frustrating. I think, Marlene, you thought maybe they had made the first one out of a material that was designed as a model instead of something solid or something long term, and the plastic just deteriorated on her. Yeah.
The initial platform was actually a low temperature thermoplastic called orthoplast, and orthoplast doesn't have a very long shelf life, so it wasn't a permanent solution, and it just cracked. But again, as Rod designed this, he made it a concave donut kind of cutout right where her distal limb was, and that just really made it a much more comfortable solution.
Yeah, it was awesome. It was beautiful. So thanks, Dave, and thanks, Marlene. Let's talk about Rhonda. Rhonda came to us because she wanted to go out on a date with her boyfriend, and she wanted to use something where she could put on her own lipstick so she could go out on date night. So actually, this particular device was created as a self-care kit for not only lipstick, but also so she could brush her own teeth. So our students at UMBC created this 3D four-prong device, as you can see, that opens and closes, and she can insert her toothbrush, a lipstick case, and any other devices she may want to use. Also, the students cleverly created a traveling bag for her because Rhonda has rheumatoid arthritis. So everything was designed around her hands and how she can hold it. So this was an amazing support system that was done for her. So Rhonda can go out on her dates, and she can also travel when she wants to, and then be able to brush her teeth on her own. So that was a great project. Let's talk about Andy. Andy lives down in Montgomery County, and Andy attends a training program where he's going to be starting a job. Andy wanted to be able to go onto his job and actually take his medication. He takes medication 3 times a day, and he wanted to have the dignity of taking his own medication. He does have cerebral palsy, so we needed to create some type of solution for him. This particular project is still underway at University of Maryland, College Park, but the 3D printed pill dispenser is here. So what the idea is, in the morning, his caregiver can actually load up his medication. Andy will be able to push a button, and then the pills dispense at the very bottom of that device. So it also is designed so that he'll be able to take some water too while he's taking his medication. So we can't wait till this project is done, and this will allow Andy to go ahead and start his new job. Let's talk about another solution. Perhaps some of you have watched your own children get on a bike and take off. And it's an exhilarating feeling to see them ride, but at the same time, it's very scary. So what happens is we have bike requests that come in. Bikes happen to be our #1 request, where parents want to see their children ride a bike, whatever their disability may be. So because of safety reasons, we needed to come up with a solution so that if they take off, mom or dad or the caregiver can actually push a button and stop the child so that they don't get away, they don't get into traffic, and they don't hurt themselves. So the students at Howard Community College, they're finishing this project up right now as we speak. They basically have created a device that will fit onto a bike, particularly in the front of the bike. Mom or dad or caregiver will have a clicker, a remote clicker, and basically when the child starts riding and if they take off, it starts to slow them down in a nice smooth pace. Our target is 20 feet. So we're really working on this project. We actually do have another project. Dave has created another project for trikes so that if a child takes off, you know, we can stop it. I know, Dave, you might want to chime in on that particular project that you've created too.
Yeah, we're trying to find solutions that fit everything. I started off with a tricycle because that's the simplest. Uh, but this is another. There's actually 3 bike remote brake projects in work. Some of these still got some work to be done on them, but yeah, the one I designed will work on. It'll actually work on bicycles also, just a matter of making the mounting. But yeah, that's so. Actually, the one I have, we've given 3 of them out, 3 or 4.
Mm-hmm.
Yeah, so
Mm-hmm.
they've worked very well.
Cool.
This one, I think they got a little to finish up on it. It'll be ready. It'll be ready for production pretty soon.
So you can see with these examples, we're not only giving safety solutions, but we're also just helping people to live their everyday lives. So with that, I'd like to introduce you to Shelbi. Shelbi Tippett has been an amazing volunteer with us. She actually started volunteering with us when she was at UMBC. She graduated with a degree in mechanical engineering. She now works for Stanley Black & Decker, and she still continues to volunteer with us from bike projects to helping us with these 3D printing projects and other custom solutions we have. So I would like to turn this over to Shelbi, and Shelbi, it's all yours.
Thanks, Angela. So good morning, everybody. I wanted Angela to start today with the examples of how we've used 3D printing in the past and how Rod has helped us, and really want to continue with that legacy of helping people with this capability that we have. And I wanted her to show those examples to get your mental gears turning, to think about people you might know that need solutions such as these. Angela has mentioned in other sessions that we have the opportunity for a very large 3D printing grant. So we really need ideas because we know people have the need. We just need to get in touch with them. And I think it's kind of a chicken and the egg, like nobody really knows that we're 3D printing capable yet, so we're not getting those requests. Or it takes some level of imagination that the client might not necessarily have. So if you see an opportunity that they haven't thought of yet, please let us know, because I would like to use it more. So far, I've mainly used it to print stuff for itself, and I also gave Dave some components for that remote braking system, which I'll actually show a little bit later. Sorry, Angela. So I know we have a mix of volunteers and just people that just want to learn more, so I am keeping it pretty basic today. This was mainly going to be for the volunteer engineers to discuss like what I can do, because I'm a novice, and you know, what kind of help I would need from them from a design standpoint and like an engineering drawing standpoint. So I want to get like a survey of everybody's kind of background. So if you have ever commissioned a 3D printed part or designed one, can you go ahead and do your little hand raise thing in Zoom? I'll give everybody a second.
Yeah, we see hand raising coming up. Hand raisings. We have 4, 5.
Okay. All right. So there are a lot of rapid prototyping, 3D printing, whatever you want to call it. This is just some of the basic form factors of what type of printing there is out there. We're going to focus on C, material extrusion. So basically we melt thermoplastics and build layers as we extrude them. And I was going to ask Angela to send out the slides to everybody, because at the bottom, or at the end of the meeting, at the bottom right, for helpful resources and like where I got the pictures and graphics and stuff in case you can't see it well during this presentation, you can follow up and click those links and learn more on your own time, because we only have a short period of time today. So a lot of cool things can be done with 3D printing, obviously. You know, bioprinting, they're starting to print entire organs. I know there was a lot of popularity recently and hype about 3D printing in the medical industry due to the pandemic. So a lot of construction for face shields, because it's mostly just a piece of plastic, but then you need the headband part of it and then the bottom shield stabilizer. Reusable masks were being printed. Components for ventilators were being printed. And just to kind of give people some engineering perspective to that, things like the ventilator parts that are going to potentially be traps for bacteria, we don't use FDM, we call it, which is the material, like the extrusion type of printing, because that has a lot of gaps in the parts, and that just creates potentially little pockets of germs. So one of our great engineers, Neil Leon, he works for Hopkins, and you know, they did studies for that, and they've been printing stuff like crazy. And he, you know, kind of gave us some insight into that world of, you know, it's a great technology, but it's not quite there in certain aspects for everything, which is the case, especially for metal 3D printing. You can do a very similar thing, but out of metal. And that I'm personally very curious to see how that evolves in the coming years, because I currently supervise a powdered metal plant, and we input powder into presses that compact them. So I'm very curious to see how quickly we can evolve into printing metal parts. So Angela, if anyone has any questions about this right now, I'm welcome to questions throughout the session. I like to be interrupted, actually, because it makes me feel like everyone's, you know, paying attention and whatnot. So if not, Angela, I can skip ahead a bit.
Okay.
So this is pretty small, and that's why I said, you know, send out the slides afterwards. But I liked this breakdown of, you have the high level of like binder jetting or material jetting, and then it breaks it down into the specific types, and then the materials that are used in that type, and then even brands of printers. So again, material extrusion, FDM, fused deposition modeling, and thermoplastics is what we're going to be focused on. Who covers cost of items? So if it is a VLink project, I have rods, mostly PLA, and that's the next slide of what PLA is. But so I will utilize all of his materials with free of charge for now or whatever. And then if we need anything specifically, Angela has, you know, the requisitions for the projects. And but if anybody needs anything, really, I'm here, I can do it, I won't charge you. I'm a volunteer, it's non-profit, so yeah. Okay, so next. So this is Rod's printer. There's a 8x10x8 build platform. It's, I don't know if this means anything to anybody right now, but it's a 1.75 millimeter kind of nozzle hole that the material comes out in, and therefore most of your layers end up being that diameter, if you want to call it. And I just put some basic specs of the printer in case anyone was curious. So it has the capability to print a lot of different materials. I've only tried PLA and ABS. I am very curious about polycarbonate. I have some TPU, and I think I printed something out of that. It's all trial and error, really. People, you know, your printer has to be capable of printing these things, but it's really up to the operator to make it come out well, because there are, and I'll show you in a bit, how many different types of parameters you can alter. So, any questions? Cool.
Okay, we'll go to the next one.
So PLA is the most common hobbyist material, even though it's, brittle, kind of degrades after a while. It works. I use PLA for the parts that I gave to Dave. And actually, that reminds me, I need to find Dave, if you have some time, can you pull up a picture of how the part fits into your whole brake system? Just like a picture or the video or something, just to put into perspective for people.
Okay, let me look while you're talking.
Thank you. So with PLA, it can be used for a lot of different things, and I think has been mostly used in the V-Link projects. Oh gosh, don't ask me to tell you what they stand for. It's I don't even remember it. I don't know the chemical names. I know what their properties are, and that's what it's important to me. Well, ABS is like a celic something. I don't know. It Google. Sorry, Amanda.
That's okay.
I should have broken that down for everybody, but I don't value the full name because everyone uses the acronym, and as long as you know what you can use the material for, yeah, polyacetic acid. Thank you. I know they're acids and whatever. So yeah. Anyway, PLA, polyacetic acid, whatever you want to call it. It really depends on how you design most of your things, because you have the options to like do infill densities, and that's pretty much how solid your part is going to be. And I go into a little bit of like the design tips for this, but this is why I don't, I know what they can be used for, but it's really also a design part of it, because you can design something a lot stronger depending on how you choose to print it and model it. ABS smells bad when you print it. It has a hanyr melting point, like plastic transition temperature or whatever, so it requires acrylonitrile butadiene styrene. Yeah, perfect. See, this is why I don't know. I passed chemistry by the skin of my teeth. No, I'm just kidding. I got an A, but I didn't like it. That's why I became an engineer, not a chemist. It's a much higher strength, higher durability, and you can use it. Hey, Dave, I see you.
Okay, I found an old video. If I guess I can share the screen.
Yeah, go ahead.
Let me try it. Let me see how. Okay.
Go ahead.
I think we're all right now.
Go ahead,
All
Stan.
right.
Share what you have.
Let's see. Gotta figure it. Okay. Can you see that? There's a.
Select the window. When you hit share, pick the window of your video.
Can you see that, or do I still have to hit something?
I think you still have to, when you're in Zoom and you hit share screen, it comes up
Okay.
with different boxes
All
of
right.
which
Let me hit
window.
that again. Okay.
Bear with us, folks. We're getting up. And if it doesn't work, Dave, you can email it to me and I can pull it up for everybody.
I'm just showing. Let's see here. Let me try this again. All right. Here's share screen.
Yep, and then it comes up with a box with all your
Okay.
windows.
Let's try that. And share.
Beautiful.
Yeah.
All right. This is actually one of the earlier ones, but you get the idea. The little white part you see is what she printed for me. Or what this is the original one.
Yeah, so I reverse engineered from a drawing and made this was actually a good example. I'll pull up the model, but when Dave asked me to print this, I wasn't comfortable. The hole that the cable is going through, it was too close to the side of the wall of the part, and it wasn't enough thickness there. And I wanted to give it some more integrity, so I just asked him, like, can this hole be smaller or moved over a little bit? And he said, yeah, it can be smaller, which gave us more wall thickness. So stuff like that. Understanding the application is really important. And he didn't know what density it needed to be, like less solid or more solid on the inside. And I just said, here, I'm gonna print 20%, 30%, 50%. Can you put it together and run some trials? And that's kind of what we're working with right now. That's why it's all case dependent.
Yep. So let me see my back here.
Thank you, Dave.
Okay,
All
we'll
right.
go.
Yeah, you can go back to the slides,
See.
Angela.
Shelby, would you like to pull up the screen, or you want me to do it?
I can.
Okay.
Let me go ahead and.
Sure. Okay, there we got her back. Yeah, one of the advantages, like Shelby was mentioning, one of the advantages of to me, of the 3D printing, obviously that was one that worked, but it was kind of a proof of concept. So like Shelby said, the hole was too big and the walls were too thin, but with some simple drawing revisions, she was able to revise that, and I have 3 of them. It turned out the 20, 30, and 40%, whatever we printed, all worked fine. So the next time someone makes it on the drawing, we updated it. But
Yep.
so I have 3 of those devices that'll work for the next 3 remote steers. But that's one of the really neat things about the 3D printing is you can just make a revision and print another part. Yeah.
Oh, so artists, that's cool. Sorry, I'm reading the chat as we go through. Well, let me get through these basic materials, and I'll point out all 3DP is the website that I used when I first started learning about all this, and it breaks everything down as thoroughly as you could want it to, and as simple as you could want it to. So it's a good way to learn about the materials and applications for those. PETG is one I'm actually really curious to try. I want to just even, I've never like held a 3D printed part that's that, but it's PET is, don't ask me for the chemical name, but it's what like water bottles and stuff are made out of. It's a lot of the plastics you find out in the like food industry. So the glycol modified makes it pretty much easy to print. And this one says it's susceptible to moisture, which actually a lot of these materials are. They're hygroscopic, which means that you can't leave them in humid areas. Really, I should have all the material like stored in airtight containers with desiccant packs or whatever to absorb the moisture. But I haven't had a problem with printing yet, but they say if it does get too filled, you can kind of bake it out in the oven. But you have to, of course, take it off of the spools and whatnot, but I haven't gotten to that point. So maybe one day I'll have a telltale for that. TPU is, I think they've, an example is like some shoe company printed a shoe out of it, like Nike or something, or Under Armour, and it's good for that type of stuff. I have a spool here. It's okay. It's kind of hard to print. Nylon, I think everybody is a little familiar with nylon. That's requires a better printer, I think. And then polycarbonate is also probably people are familiar with, like plexiglass type of stuff. It's pretty strong, can sit outside kind of, or not, no, actually it can't sit outside. It's one of the bad ones for being outside. Yeah. So for artists, it's funny you said that because I was talking to a new person a couple of weeks ago that I just met, and she is an artist. And she knew I was an engineer, and I said I had a 3D printer, and she said, "Oh, what kind of art do you do?" And to her, inherently, just coming up with, unique designs and creating a thing is art in their mind. And I always kind of figured it as engineering, but a lot of engineering is actually art when you think about it. There are tons and tons of maker spaces that have 3D printers, and they were actually a big part of the pandemic response in printing face shields and masks and stuff. So the artists and the scientists kind of combined recently. Clay extrusion, yeah, that's cool. You can print a lot of things. I mean, they 3D print with material like extrusion, you can do it with cement and print entire houses. Yeah, pancakes, I think they like to do, pastries and whatever. You can print using pancake mix. Oh, they have 3D pots at Clayworks in Baltimore. That's cool. So the opportunities are endless, honestly. It's just, you know, we need the creativity to come up with it. On a personal level, I can use the printer for, I like to use it for like buttons and stuff. That is kind of hard to find, but still made of plastic, and you can easily reverse engineer. On my list of to-do things, my boyfriend has a coffee grinder that had like one of the big ones that has the doser in it. If you've ever seen them kind of click the handle at Starbucks, he doesn't want that big thing anymore. So he designed a part that'll just, we'll mount it to that. And, you know, plastic has a lot of opportunity in your life, because I feel like ever since the 50s, everything's been made out of plastic. All right, Angela, let's pop ahead. Oh wait, I'm driving now. Never mind. Let's see. Do I know how to click through? I'm not actually sure I know how to. Why is this not working now? Oh, there we go. Okay. This is PLA versus ABS. Because I have both, and this was geared a little more towards our volunteer engineers. I have both. I can print in both. Sorry, this little window keeps getting in the way of things. So this is just a breakdown of, I don't really have a preference. It really just depends on what you want to use it for. They're both inexpensive. They're both equally kind of crappy. It's just that ABS tends to be a little bit stronger and a little more flexible. And again, all 3DP is a good source for this stuff. So some design tips. So like I talked about with Dave, we had a hole that was too close to a sidewall, so I altered that. And something I wanted to mention is, if you've ever heard of CAD modeling, you create the part from nothing in that CAD software, and then you save the part as an STL file, and then that's when it becomes a printable part, sort of. I'm going to go into the software in a minute, but just so we're all on the same page of, if you send me an STL file, I can't make changes easily. There are ways to reconstruct it and like put the mesh back together, but it's very time consuming and usually doesn't come out well afterwards. So like when I had to make this change, Dave didn't have the original model, but he had a drawing, so I worked backwards from the drawing, and it was such a simple part that it took like 10 minutes to actually model, but that's that. The tolerance on things is okay. It's not great. I don't have specific numbers. It really depends on the orientation of the part. If it's a horizontal hole, it's going to be worse than a vertical hole usually. I've found that usually towards the end of a 2-hour-long print, I don't have an explanation yet, but a layer will just kind of be a little shifted, a little cockeyed. And I actually have some parts, so I can, give me a sec. I can show you what I mean. Let's see here. Gotta find the right dimension to show you. This one's not a great example. Where's another part? I just got 3D printed parts laying all over the place now. Let's see. So this is kind of an example of some of the resolution I get on a bottom layer print. This was not designed by me. You can see how the edges, it's not clean, but then it gets better, but you can kind of tell some of the layers aren't like perfect. They just shift a little bit left or right. You also can get problems with warping on the bottom. If you see how it's supposed to be flat, I discovered early on that if you put Elmer's glue, a very thin layer of Elmer's glue on your print bed, and you let that dry before you heat up the bed, that you'll get rid of that warping pretty much. That was a good trick from the 3D printing friends that I have. Someone also told me that if you mix acetone and ABS, like you make a slurry, you can kind of paint that on to the bed and let that dry, and that'll have the same effect. So, support material. I think this is better explained if I show you what I mean by support material. So give me 1 second to switch. Stop. Share different screen.
While she's doing that, do you guys have any questions along the way? Okay.
What CAD software type of files do you usually work with? So all of college, I was in SolidWorks pretty much, and then all of work, I'm in CATIA now, and then at home, Autodesk Fusion 360, because Fusion also has a CAM software that creates GCode for CNC machines. So, and it's free, so I use that. But yeah, I've pretty much used, and I've used every single CAD package there is, really. I think just because SolidWorks was what I started with, that's what my brain defaults to sometimes, because it's, if you've never used different ones, it's hard to explain that, like, the controls are different with how you manipulate parts, and it gets annoying. Like, you've learned muscle memory for a certain thing, or it trains you to think a certain way. It's like certain aspects of a part geometry, they give you like helpful buttons to do it quickly, and they're not always the same names in different softwares. So I find myself like, I know what I want to do now, what would this software be calling it? So I don't recommend jumping through a bunch of different ones because it gets confusing after a while. Learn one and stick with it. All right, so support material. Let's see. I don't know if this one actually has any. 1 second. Oh, and I guess I should explain. So what we're looking at is, after we've created the CAD model, I import, here, let me just show you. I just import a file. So like I've now put 2 of them in there. So this is a CAD model, and you can manipulate the part in this plater, they call it. So I can rotate it to the orientation that I want to print it. So rotate. So now it's flat. And this is pretty much because, and a little bit into the thought process of how you orient your parts, this is a very big hole, and I want that to be the vertical one, just to be more stable, I guess, and to not have to use a lot of support material. They have rules of thumbs with horizontal holes. So if you think about it in like, what's a good example? Jenga or something, where you're trying to stack things on top of each other. If you wanted to use building blocks, you need to like put a base layer and then put one on top of it and have it be a little scooched over. So you're always creating in hole patterns, that are horizontal. You're always creating this like step, 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 step. So you can get some distortion. They actually recommend, if you can, make it a teardrop shape, because that'll be less distorted, and basically the bottom of the teardrop will be the ID that you need, and you can just like drill out the size you need, because otherwise you might collapse in on yourself. And that's where like your cooling rates and your fans come into play too, because if you don't cool it fast enough, it'll just fall into itself sometimes. So I don't, hold on 1 second. I thought this one would show you support material. Come on. Maybe you can see it in the layers. So you can manipulate the parts however you want, and then this will break it down into literally each. Here we go. Now you can kind of see the support material. So these black lines and whatnot. Anything that's not in the body of the part is what it automatically thinks you want to have. So these are for the through hole that's horizontal there. I see a couple questions. Let me pop over to the chat box. Ah, okay.
We're good.
Good.
Yeah, we're good.
All right. Let me, hold on, switch back to the slides. I'm also running 2 monitors, so this is getting a little confusing.
We're also going to allow some time for questions too, so start
Oh,
putting
yeah.
the questions together.
All right. So on the topic of support material, anything that overhangs is going to automatically generate that. There's a YHT rule. So remember how I talked about those building blocks? Things with Ys are going to be better for you because it can almost support itself if you do it right. H is like a bridge, and there's some rules of thumbs with the bridging of how thick it is and how far across you can go until you don't until you need support material to generate. But then T's are always going to need support material. So keep those things in mind. So round crests and roots on threads. That might not mean much to many people. Basically, if you've ever seen a screw, it has sharp, edges because it's digging into something. For 3D printed parts, that doesn't really work. You can't maintain those fine edges. So try to round those profiles off. Taps and dies, anything less than 1.6 millimeters, this is just another rule of thumb. You're going to, for threads less than that, you're going to want to just tap or die it. Fillets and chamfers and rounding, it doesn't hurt, especially on bottom layers. It'll help avoid that curling, the warping that I showed you earlier on parts. So it doesn't need it, but it can't hurt. So I try to round off stuff, but like what I did for Dave, I didn't round off at all, and it seems to work. And again, it all just depends on the application. So like that was a direct load. It has the little like step to it on the top, and that was just like direct this way. So if I would have had any moment on that, I would have probably tried to give it a little bit of a fillet, just so it doesn't like break off and the layers don't peel away from each other. And this is how 3D printing is a little different than just like machining a part. Clearances, tolerances, pretty much you have to determine after you've printed the part. Every printer operator is going to be different. And then usually I just say if it's holes, make it smaller and drill it to the size you want to make sure, especially things that are going to have support material in them. It's not clean, and all the parts that I made for Dave, I ended up cleaning up. And then I think he cleaned up what I cleaned up afterwards too. And then wall thicknesses, we talked about it. The rule of thumb is 2 to 3 times your nozzle width. So I said it was 1.75 millimeters for this printer, so I don't go any smaller than that. All right. So this is the soft. Oh, sorry, hold on. Move this little box. So GCode is what your printer, like the language your printer needs in order to actually do the paths. In the slicer, as I said, you select your infill densities and the patterns. So on the left here, this is what those percentages will look like. So I did 20% for Dave's parts, and he said that worked, and that's just because of the application that works. Mm-hmm. You can do like honeycomb style, you could do rectangular style. It's also where you establish all your supports. So these are rafts, brim, or actually bottom up is a raft, which is to get the best like adhesion and ensure you don't have warping. You would build it completely off of a layer of material that you don't need and you're just going to break off at the end. Brims kind of come off of it and help hold it down. Like I don't have a good example. And then the skirts, the skirts are usually, for me, I just use the skirt to clean the nozzle head out and to make sure I have a good first print. Do you talking, watching, and how much? What does that mean, Darlene?
Darlene, are you on the call? Are you able to elaborate a little bit more?
Okay. Well, when she finally comes up. And then, yeah, as I said, manipulate the model however you need it to print. And now my thing's not working. Okay, so that I use a printer interface, like a thing that controls the printer itself, that has the slicer kind of built into it, but I wanted to introduce them as two separate things. So print run is the name of it, and it allows you to branch out into the slicer software and do things in that without leaving this user interface. Let me just go ahead and open that up because to make the picture larger.
And Shelby, while you're pulling that up, you might want to share a couple of tips if people are listening and they want to get their own 3D printer. Can you kind of just step them through like what they need, the printer, the software, the materials, just a quick rundown real quick.
Yeah, a lot of the printers, I think people like MakerBots, Lulzbots. There are a few other like low-ish cost printers. Rod's printer was in the middle somewhere of like really cheap hobbyist and then like a super expensive hobbyist type printer. So I like it. I think it was a great starting point. So thank you, Margie, if you're still online. The software, so Slicer and Cura are the slicer softwares that are free. The more expensive printers have their own software suites, and you don't need to use them. They're not necessarily any better. Like everyone uses these and they work fine. Print Run, I think, is specific to a few different, sorry, the windows keep getting in the way, a few different types of printers. This software that I have up right now. Yeah, it really just depends. If you have to buy the materials that the printer is capable of, and you have to use the software that interfaces with the printer. And if you go, you know, hobbyist, it's pretty much always going to be free online to download.
And I just got a question that was sent to me asking about the temperature in your home. Do we need to be concerned about temperature as far as setting up the printer and the materials and any of that?
Yep. Yeah, absolutely. I ruined a print once because I left my window open and my printer is on my desk and right next to my window. And I think this was when it was cooler outside. And it just came out horrible. And I was like, what happened? And then I realized I had the window open the entire time to try to vent the, the heat and the fumes. And that was just so silly of me. The temperature in the house, not so much, but anything that has depends. If you're under one of your HVAC vents, yes. Something that's actively creating airflow over your part and leaving the window open, but ambient temperature, I wouldn't worry about it. Your printer and this software has feedback to know how hot it is. It has thermistors, so it turns on fans according to what it's getting that feedback of.
Right.
Good question. Yeah. All right, so let me show you what this does. It works just like the slicer, kind of, in terms of, hold on, it's loading the part, or it should be. It might take a while. I'm using a lot of computer thinking power. But this is a plater. You can, let's say you have 5 different parts that you want to print. you can load them all into here and it'll build the code to print all 5 of those parts at the same time, or at least in the same print cycle. I don't know why this isn't working. This will also show you the actual path that the extruder is taking. I could show you if it would load.
Well, as we have 5 more minutes left, are there any questions? And then before we leave, I wanted to flip back to the first picture of the guitar too, to show folks.
Yeah. So, but just briefly, so this up here on the left, I can adjust the motor speed. So that'll take care of how fast the X, Z, and Y axes move. And then this is these little like brims and buttons actually move the printer and print head. And then I have my extruder temperature and my bed temperature, and this little graph right here shows you as it rises and then it hits that set point and controls it to keep it at that temperature as best as it can. And yeah, a lot of feeds and speeds pretty much. If you've ever done any CNC stuff, it's the same. It's the same G-code that anything uses in the whole world. So, all right. Let me switch back to the slides then, since that decided.
We have a question. Does the average home have things in it that contain 3D parts? The average home, can you think of anything in the home that has 3D parts?
No, but it has a lot of things that are plastic that you can 3D print and replace them with. So 3D printing is still pretty much in the prototype realm. It's not, they have production grade printers for things, but it's not used as much. I mean, plastic injection molding is still king and will be for a long time. But people like rapid prototyping because it's rapid and you don't have to spend, 30 grand or whatever to machine molds. But if you're going to make millions of parts, it's not there yet. The technology isn't there. So that's why you don't see it in your home right now. And that's why it's a hobbyist thing right now. I know I sit in a lot of like tech startup things that are trying to make 3D printing easier and CAD modeling easier. And, there are grab CAD sites where I could print anything that anyone's designed and put on that site. Like this was something I did not design. I just grabbed the file and printed it one day. But yeah, like I said, buttons and that's what I use it for, is like buttons and things small that are plastic in the home. You can, if you know how to reverse engineer it to design it, like take measurements and design it, you can print it. Or I can, if you want me to.
Well, as we prepare to wrap things up, this picture of a guitar, if you're a rock and roll type of person, it was done for one of our clients, Rob. He had an accident and had a C4 spinal cord injury. He's an artist, he's a musician, he's a community activist, and his biggest thing is he wanted to get back into his music. So a team over at UMBC actually took the guitar and they did a lot of 3D printed parts. All the white parts that you see, not the faceplate on the guitar itself, but the small 3D printed parts on the neck, yes, and a little further down, that's actually, yes, in that particular area, all those parts were 3D printed and customized for Rob. So basically, this is a support for Rob that he can just put on his lap, and he can play chords. It doesn't allow you to do all of the full playing, but it allows him to do chords on the guitar. So that was a really cool project that really got him back into music.
Yeah, I liked that one.
Yeah, it was really cool.
Yeah, so the options are there. You just have to, have the creativity to come up with something. Plastic can be a little limiting. I think that's why it's not, fully everywhere in our lives. But
Mhm.
so how do I adjust when a print fails? It all depends. If I get that weird layer shift thing, it's just kind of like, does that matter to the application? If not, even though it looks like crap, I'm still gonna, deliver it because it's not hurting anything to the design. Like aesthetic things like this, like that's not make it or break it for me. So I'll just leave that part as it is. I actually had to redesign the spool holder on the printer because not all the spool hole sizes are the same, and a spool actually popped off the printer one day and like broke the filament off while it was mid print. So I kind of babysit a little bit to try to catch those errors quickly and adjust accordingly. But yeah, it really all depends. If it's temperature stuff, I can control the fans and the temperatures. The bed adhesion, I learned pretty quickly how to fix that with glue. I still can't believe it's just glue. Like Elmer's school glue fixes it. Yeah, and that it is actually kind of painful sometimes when you think about you could print something for 6 hours and something could go wrong in the last part of it that would make you have to start all over. And I think that's why I wasn't fully sold with the technology before. But now that I've used it, I think I'll always probably just keep a 3D printer around to replace all those little things in my life. So.
Well, we've hit the 12 o'clock hour, but we're willing to stay on if people want to, ask more questions, but we want to respect your time.
I am good. So if anybody needs to jump off, thank you for coming, or whatever, virtually.
Yeah, thank you. That was
Virtually.
very interesting.
And the slides this will also be on our YouTube channel. So if you want to take a peek at it and review it and share it, and even ask us questions. And if there's anyone who's interested, who wants to help us with all these solutions, I'm Angela Tyler, so you can definitely get in touch with me. I'll be glad to talk with you. Or if you know any clients particularly that need solutions, let us know. We want to help.
Yep,
okay,
absolutely.
but we'll stay on. Thanks for coming.